In the next video, I will show you the squeeze theorem, but I'm going to use this video to highlight an idea that will lead us to the squeeze theorem. So if you look at f of x equals sine of x, it would be a graph that looks like this. It will oscillate between positive 1, negative 1, positive 1, negative 1. So the highest value that this thing could be is positive 1, and the lowest value that this thing could be is negative 1. Now, if you start combining the sine of x here with x squared here, it will look like this. So your graph will basically look like this. It will basically do this, okay, and then it will do something like this. And the reason for that is because if you look at this here, you've got x squared times sine of x here. So, well, hang on, let me show you this. So your normal sine of x will look like this, something like this, okay, and then your x squared will look something like this. Now, if you look at, well, I'm going to use this as an imaginary x squared here, negative x squared. If you look, so at the moment we've got x squared, times sine of x. Okay, so we've got one block times another. Now, if you look at this here, sine of x here is 1. Now, 1 times x squared, that would take you to here. Okay, if you look at here, sine of x is 1. Well, when you times x squared, that would take you to up here. And then if you look at this bit here, sine of x would be 0. Now, anything times 0 will be, well, this bit here will be 0 times x squared will be 0. So anything on here, it will remain on that line. So really your graph will look something like this when you start to combine the two. Okay, and then if you look at this point here, sine of x is negative 1. Now when you get negative 1 times x squared, that would take you to negative whatever x squared is down here. So your graph will look something like this. And then if you look at this point here, it's negative. Sine of x will be negative 1, and then you times x squared, that would take it to somewhere down here. So your graph will go all the way down here, back to the 0 here. And then this point here is negative 1, so it gets dragged down here. So your graph will end up looking like this. That's why this graph here looks like this. It's being encapsulated by x squared. Okay. So now if you look at f of x equals sine of 1 over x, it will look like this. So I've done. If you don't understand this function here, watch one of the earlier videos. Okay. But as you head towards 0, it oscillates a lot faster. Now when you start to combine this with x squared, hang on. So start combining this with x squared. So hang on, let me start here. So this here is your sine of x. Okay, so as you head towards 0, it will oscillate a lot faster, and then it will decrease and so on here. So sine of x, sine of 1 over x will look like this. Now let's start to combine this with x squared. So we're going to look at x squared. So we're going to get this block times this block here. Okay, it will look like this. So your sine of x will look like this. Now, you see, so you've got one block here times another block here. Again, it's being encapsulated by this x squared here. Because if you look at sine of 1 over x here, the highest value that this could be is still positive 1. Because look, the highest value, this is positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, well, the highest value that this thing could be is positive 1, and the lowest value that this thing could be is negative 1. This here is just like your sine of x, but the only difference is that it oscillates a lot faster as you head towards 0, but the height or the amplitude is still the same as sine of x. It's still being, well, the height is positive 1, -1, +1, the height or the amplitude will still be the same as sine of x. Now, when you start to combine it with x squared here, it will do this. Okay, the point here is that the highest value that this thing here could be is 1. Okay, so if you look at the highest value this whole function, the highest value that this whole function could be is, well, this is the highest value that this could be is 1. So if you get 1 times x squared, the highest value this whole thing could be is x squared, because this thing here, the highest value that this thing could be is 1. So 1 times well, at the highest value it would be 1. This thing here will be 1 times x squared. So the highest value that this thing could be is x squared. So that's why the highest value is here, is x squared, and the lowest value that this whole thing could be is the lowest value that this thing could be is, well, the lowest value would be -1. Okay, and then when you times x squared here, whatever this block here is times a negative number, it will be a negative. So that's why it's down here. Well, the lowest value that this whole thing could be is minus x squared. Okay, so this function here, f of x here, this whole thing here is really encapsulated by x squared and negative x squared. It's always in between. X squared and negative x squared. The whole point of the squeeze theorem is that, now if you know that if you know the limit of this, let's look at the limit as x heads towards 0. Now the limit of this is as x heads towards 0, well, is heading towards 0, and the limit of this here is also 0 here. Then because this thing is in between the two, then you can also say that this thing here heads towards 0. I know it's a bit confusing. My point is that this function here is always this function here, f of x here, our function here, which is this one here, is always greater than minus x squared, but it's always less than x squared. So if the limit of this heads towards 0 and the limit of this heads towards 0, then we can say that this whole f of x here, this whole f of x here will also head towards 0. I will elaborate more on this next time, but the idea is that if you're told that a function is in between this one and this one here, and if this one is heading towards a certain point, and this one is also heading towards the same point as this one here, which is in this case here 0. This is in between the two, so it's got, well, if the limit of this here is 0, and the limit of this is also heading towards 0, because this is in between the two, it must also head towards 0. I will elaborate more on this in the next video, but that's just a rough idea. Okay.